Hello everyone, today I'm going to start with KNN algorithm, which is the first part of our chapter 4, module 3. KNN algorithm is a part of a supervised learning algorithm. It is used for pattern recognition and data mining process. It is very easy to implement, so people use this KNN algorithm. Even you have seen so many projects where they need some of the data, like some of the data set is given to you, and then based on those data set you have to find a last predicted class or category, which is the output. So in that case, KNN algorithm is used. In this KNN algorithm, no assumptions need to be made, so it is very easy to be implemented. So first, what is the input you can take? You are given with the data set. Along with the data set, the training data set will be given. One test instance will be given to you along with this training data set, and for that you have to find the Euclidean distance. After finding the Euclidean distance, as you can see here, we have to find this. Already the k value will be given in the questions, like here this k value. So k value will be given in the question, and based on that k value, you have to find the least Euclidean distance. Based on that, you will make a prediction about the predicted category. So let's take the example of this data set. Consider the student performance dataset of 8 data instance shown in table 4.2. This is table 4.2, which describes the performance of individual student in a course and their CGPA obtained. The independent attributes are CGPA, assessment, and project. Why these are called independent attributes? Because it is not dependent on anything. This result is a dependent attribute or a derived attribute, you can say, because based on CGPA assessment and project submitted, either the person will pass or they'll fail. So this is a result is a dependent attribute. So this is our question which is given to us, and now based on this data set we have to classify like whether a student will pass or fail in that course. So CGPA assessment and project is given to you. Now a test instance will also be given to you in the question. So the test instance is 6.1, 40 and 5. And the k value is also given to you. K is equal to 3. Now we have to find the Euclidean distance. So Euclidean distance is nothing but root under x1 minus x2 ka whole square plus y1 minus y2 ka whole square. So 9.2, 85, 8 is given to us, and 6.1, 40 and 5 is given to us as a test instance. Based on this test instance only we have to check and we have to predict the category. So 9.2 minus 6.1 ka whole square plus 85, which is the assessment marks, minus 40, which is the given test instance, plus 8 is the total project submitted, and 5 is the test instance. So 8 minus 5 ka whole square. The answer which you are getting here is 45.2063. Now after this you have to find the Euclidean distance for all that data. So here you can see we have founded the Euclidean distance for all the data set which is present based on the test instance. Now as you can see, we have to find k is equal to 3. K is equal to 3 is given by k is equal to 3. K is equal to 3 is given as we have to find only 3 um, distances based on this Euclidean distance. So the 3 least distance is 2.022375, 5.001 and then 10.05. Three distances we got. So after these distances we got, we have to sort this and we have to write it here based on the instances. Now based on the instances only you have to do the sorting, like 4, 5, 7. These are the instances, the Euclidean distance we have found, and the class. And now the major voting will, if the major voting goes to fail, then the predicted class will fail. Suppose all these classes would have been pass, so the predicted class would have been pass. If only two of them would have been pass, then also the major category was pass only, so the predicted category would have become pass. So here in this case all the category is fail and the majority is fail, so the class for this test instances is predicted as fail. So this is all about KNN algorithm. So KNN algorithm is nothing but here you will be given a training data set in the question itself. K value will be given to you in the question itself, and the test instance will be given to you. Based on that, you have to find the predicted class or category. First of all, you have to calculate the Euclidean distance. Based on that Euclidean distance, you have to find the first, based on the K value, you have to find the shortest distance, least Euclidean distance, you can say. And then after finding the K value, you have to predict the class with the majority voting. So here the majority weighting goes to fail, so the predicted class is also fail. Now we'll come to weighted K nearest neighbor algorithm. Here also everything is same, but here you have to, after the Euclidean distance, you have to find the inverse distance, and after finding the inverse distance, you have to find the weight, and then you have to predict the class. So coming to the algorithm for weighted K nearest neighbor, first of all input is given as training data set, distance metric, weighting function, test instance, and the number of nearest neighbor, and you have to find the predicted class or category. So the for the test instance T, you have to find the Euclidean distance from all the training instances. Now after finding it, again you have, based on the K value is nothing but the nearest neighbor value, you have to find the least Euclidean distance, and then you have to sort them. And after sorting, you have to the third step is like predicting the class. So in that third step only, you have to compute the inverse. After computing the inverse, you have to find the sum of those inverse, and then compute the weight by dividing each inverse distance by the sum. So weight is founded by dividing each inverse by the sum, and add the weight of the same classes. The classes which are same, you have to add weight for that, and after adding those, whichever class has the maximum vote will be the predicted class. So here we are doing some 5 extra steps. So first, uh, same data set is training data set is given to us, and we have 7.6, 60 and 8 as our test instances. K is equal to 3, nearest neighbor value is given to us. So we have founded the Euclidean distance here. The Euclidean distance is 25.05115, and after finding all the Euclidean distance, you have to find the least Euclidean distance. So the least Euclidean distance will be here. First of all it will be 12, then it will be 10, and then it will be 15. Yeah, it will be 10, 12 and 15. Now you have to sort it based on the instances. Now we have to predict the class. So we have to for all these Euclidean distance we have to find the inverse. So 1 by 15 is nothing but 0.06502. 1 by 10.82636 is nothing but 0.092370. Now all these inverse distance we have founded. After finding the inverse distance, we have to find the sum of these inverse distance. The sum of these inverse distance is 0.24033. Now after finding the sum, we have to compute the weight. So how the weight will be computed? Inverse distance divided by the sum. Sum is like 0.24033. 0.06502 divided by 0.24033. So the weight is 0.27054. Now, like this only, all weights are calculated. After calculating all these weights, the classes which has the same value will be added up together. Like this fail values will get added up together. So these two values are added and this pass value will remain like this only. Because no other values are there, or else if it would have existed, we would have added it. So 0.654892 and pass is like 0.345109. So the greater value is, or the highest value we can say, the majority vote goes to fail. So the class predicted is fail. So this is all about our weighted K nearest neighbor algorithm. It is also a part of our supervised learning only, and these are used for classification purpose. So this is all about our weighted K nearest neighbor algorithm. I hope this algorithm is also clear to you and how to solve is also clear to you. Now coming on to the next algorithm we have in this chapter is nearest centroid classifier. This is also a similarity based classification, and here we have to find the centroid or mean you can say, and again you have to find the Euclidean distance and then you have to predict the class. So we are given with a training data set and the test instances. So here are all the training data set. This is the these are the classes A and B. We have A and B. First of all, if these classes are jumbled up, you have to make appropriate table for that. So like A are together or B are together, so that once you are solving this question, you don't end up getting confused. So the values are 3, 5, 4. Now we have to find the centroid or mean. So 3 plus 5 plus 4 divided by 3. Here the centroid of class A, 3 plus 5 plus 4 divided by 3. Now 1 plus 2 plus 3, which is the y values. So the answer will be 4 and 2. This is the centroid of class A. Now class B, similarly we can find out 7 plus 6 plus 8. 6 plus 7 plus 5 divided by 3. So it becomes 7 and 6. So centroid of class A and B is founded. Now we are given a test instance 6 and 5. This based on this test instance, we have to find the Euclidean distance. So the Euclidean distance is like 6.4 ka whole square plus 6 minus 4 ka whole square plus 5 minus 2 ka whole square. So it will become root under 13. The answer will be 3.6. And here for the second one, like for class B, the answer will be 1.14. So the smaller distance has like the test instances has smaller distance to class B. The distance is 1.414, which is in comparison to 3.6 is lesser. So the predicted class will be B. So these are the three algorithms we have to study in our fourth chapter of the third module. The first one we studied was KNN algorithm, in which we have founded the Euclidean distance, and then based on the Euclidean distance, you have to check for the least distances based on the k value. So after finding the least distance based on the k value, you have to take the majority vote and you have to predict the class. In the weighted k nearest algorithm, we have to find the weight, and after finding the weight we have to predict the class. And in the last one, which is nearest centroid classifier, first of all we have to find the centroid or mean we can say, and then the Euclidean distance. Based on the smaller distance we have to predict our class. So this is all about our three algorithms.